Hi everybody! Today we will talk about the electronegativity. In the figure of the periodic table that we use here, 4 numbers are given for every element. We already discussed the atomic number and the atomic mass, so today we talk about the third number, the electronegativity. Okay, so what is that? Electronegativity describes the atom's ability to pull on electrons in a bond. Let's explain that by looking at water. A water molecule consists of an oxygen atom bound to 2 hydrogen atoms. To understand what influence the electronegativity has on this molecule, we first have to look up the values. Hydrogen has an electronegativity of 2.2. The one from oxygen, on the other hand, is 3.44. Perfect! Now we can continue. The electronegativity of oxygen is higher. Therefore, it pulls the electrons in the bond stronger. And what does that mean? In this figure, the electrons in the bond are shown as black lines between the atoms. But actually, they are not located in the middle, but more towards the oxygen. Therefore, the oxygen is slightly negative, which we call negatively polarized. It is not negatively charged because then it would have to take up the electrons provided by the hydrogen atoms. But it is slightly negative. On the other hand, the hydrogen atoms are slightly positive. They are positively polarized. Just another information about the numbers. We cannot measure electronegativity. The 0 point and the unit are arbitrarily chosen. The numbers only show the relative ratio of the electronegativities of the different elements. Since this is arbitrary, there are different scales for electronegativity. We use Pauli scale. Let's look at how the electronegativity changes within groups and periods. In general, one can say that the electronegativity increases from left to right. This makes sense because 1 proton is added to the atomic nucleus every time when going from left to right. With the additional positive charge, the electrons can be held more tightly. Additionally, the electronegativity increases from bottom to top. This seems weird, since the number of protons increases from top to bottom. But with every period, the outer electrons are further away from the nucleus and cannot be pulled on so tightly. The outer electron of a hydrogen atom is in the first shell and is therefore pulled on more tightly than the outer electron of a sodium atom, which is located in the third shell. This was a more detailed look into the electronegativity. If you have questions, suggestions, or tips, leave them down in the comments. If you liked the video, like it and subscribe to my channel. See you in the next one.